In the last video, we explored a particle moving according to this law of motion, which has a quotient rule in order to take the derivative, and we found velocity. And now we're going to do a little bit with acceleration. So we're going to take the derivative of velocity to find the acceleration function. This is a tough derivative to take because the derivative is going to involve a quotient and a chain rule. So looking at our velocity function, the derivative of the top, derivative of 16 minus 4t squared, is just going to be a minus 8t. The original bottom is t squared plus 4 all squared, minus the derivative of the bottom is a chain rule. So we're going to take the derivative of the outside times the derivative of the inside. So derivative of u squared is 2u. So 2u to the first, 2 times t squared plus 4. And then the derivative of the inside piece, t squared plus 4, is 2t. That's the derivative of the bottom, which gets multiplied by the original top. 16 minus 4t squared. All over the original denominator gets squared, so we'll have t squared plus 4 squared getting squared, or t squared plus 4 to the fourth would be faster to write. The next part says, when is the particle speeding up and when is it slowing down? In order to figure that out, we need to see when velocity and acceleration have signs that are the same. So we're going to need to figure out, when does this velocity and acceleration have the same sign, which means first, when does this acceleration equal 0? So that we can make a sign chart with it. This is going to be a tough one to make a sign chart with because we are trying to figure out, where does the numerator equal 0? If the numerator is 0, then the whole fraction is 0. So we're going to do a lot of work to simplify that really big numerator. So I'm going to take it term by term and just start with this left side. So we have this 8t times t squared plus 4 all squared. Well, first of all, we can square out that t squared plus 4. So it'll be t squared plus 4 times t squared plus 4. And so when we square that out, t squared times t squared is t to the fourth. The outer and the inner term are both going to be 4t squared. So 4t squared plus 4t squared is going to be 8t squared. And 4 times 4 is 16. Or you might remember the perfect square trinomial formula. Then we need to distribute that negative 8t to what we just found. So negative 8t times t to the fourth plus 8t squared plus 16. So we get negative 8t to the fifth minus 64t to the third minus 128t. So we just simplified that first part, the derivative of the top times the original bottom. Now we're going to continue trying to distribute and look at this next term here. So first thing I combine pretty easily could be the negative 2 times the positive 2t. So when we do that here, just trying to simplify this as much as possible to start, negative 2 times positive 2t is going to be negative 4t, and that's going to get distributed to t squared plus 4. And then we can multiply it with 16 minus 4t squared. So first, just distributing this negative 4t in here is going to give us negative 4t cubed minus 16. And then we can FOIL it with that 16 minus 4t squared. So when we do our first term, we have negative 4t cubed times 16, which gives us negative 64t cubed. Then our outer terms, we have negative 4 times the negative 4 is going to be positive 16t to the fifth. Our inner terms, we're going to have negative 16 times a positive 16, which is going to make it, and that has a t on it. Negative 4t times positive 4 gives it negative 16t. So that inner term is going to be a negative 256t. And then lastly, negative 16 times negative 4 is going to give us a positive 64t cubed. So at least this negative 64t cubed and the positive 64t cubed can combine. And then we can put it with the other part of the numerator, which was a plus 16t to the 5th minus 256t, going with what we had off to the side there already. We're trying to set this equal to 0. So one thing we could do is combine some like terms. So we have 8, or negative 8 and 16 rather, which is going to give us a positive 8t to the 5th. And then next we have a negative 64t cubed, nothing to combine with that, but we can combine negative 128 minus 256 to be a minus 384t equals 0. I'm going to try to factor this by pulling out an 8 and a t. My greatest common factor would be multiplied with t to the 4th minus 8t squared minus 48, and we're going to set that equal to 0, which is kind of nice because we can just reverse FOIL that. So 8t, and then it's going to be t squared and t squared here. We want to multiply to be a negative 48, so I must have a positive times a negative. It's going to be plus 4 and minus 12. Now we used the square root method earlier with velocity to solve it, and we're going to do the same thing here. 8t equals 0 when t is 0. T squared plus 4 equals 0 when t squared is negative 4. So t equals, well, you can't take the square root of negative 4. So we're not going to get a t value there. But t squared minus 12 equals 0. We would add 12 to both sides, and we can take the square root of a positive number. So we will get some t values for that. We're going to get plus or minus root 12, which is about 3.5-ish. So when we compare our sign charts, we did the velocity sign chart in the last video. We said it switches at 2. Before 2, the velocity is negative, and after, the velocity was positive, looking at that sign chart above, and after 2 it was negative. And we're comparing that to acceleration, where we have 0, and we can't plug in a negative t value, so we're not going to have negative root 12, but we will have positive root 12. Which is about 3.5. So we're going to plug in something before 3.5, so maybe 1, into this acceleration function. So we can plug into the simplified numerator. That looks like this. This is the numerator. We can plug in 1 there and see that we'd have a positive times a positive times a negative when we plug in 1 to the top, and the bottom is being raised to the 4th, so it's always going to be a positive factor. So the acceleration is going to be minus when we plug in 1, and we can plug in after root 12 or 3.5 any number we want, so I might plug in like 5 into this factored form or into the original form. You should get the same answer. 8 times 5 is positive. 5 squared plus 1 or plus 4 is positive. 5 squared minus 12, 25 minus 12 is positive, and in the denominator it's raised to the 4th power, so it's always positive. So when do the signs match? Because that's going to be when we're speeding up. And when are the signs opposite? Because that's going to be when we're slowing down. So to start from 0 to 2, 0 to 2, so 2 is going to be before root 12 on this lower sign chart. I could try to line them up a little bit better. So there's 0 to 2. They have opposite signs. So it is going to be slowing down from 0 to 2. After 2, we have this period after 2 where the acceleration is still negative and the velocity is also negative. So we are going to be speeding up from 2 to root 12. Right in here, they're both going to be negative. From 2 to root 12 are about 3.5. And then after root 12, after about 3.5, the velocity is still going to be negative, but the acceleration has switched to be positive, so they're going to be slowing down again. So from root 12 on to infinity. They have opposite signs, so it's slowing down. So a ton of algebra in this one, but we were able to figure out when do velocity and acceleration have the signs match, so it's speeding up, and when are velocity and acceleration having opposite signs, so that it's slowing down.